Question number 1. A particle is moving on a curve as the position given by x is equal to f prime of t sin t plus f double prime of t cos t, as well as y is equal to f prime of t cos t minus f double prime of t sin t at time t. Now the velocity of particle at the time t that we have to find. Now as we all know that if I want to find the velocity of any particle, that is equal to square root of dx upon dt square plus dy upon dt square. So what you have to do is first find out dx upon dt. So dx upon dt is equal to, now differentiate this term with respect to t, that is f prime of t into cos t plus f double prime of t into sin t plus f double prime of t into minus sin t plus f triple prime of t into cos t. Similarly, dy upon dt, so that is I can write f double prime of t cos t minus f prime of t into sin t minus f triple prime of t sin t and minus f double prime of t cos t. Now here you can see that in dx upon dt, now f prime of t cos t, f double prime of t sin t, plus and minus will get cancelled, removing cos t as common factor, as well as in this term f double prime of t cos t minus f double prime of t cos t will get cancelled. So this dx upon dt, it will come that cos t as common, f prime of t plus f triple prime of t into cos t. Put this value here, as well as I can write in this form that f prime of t plus f triple prime of t into minus sin t. Similarly, put this value here and squaring, you will get the answer. Now, question number 2. Before we start question number 2, the function is given. As we all know that the exponential series is given by 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial up to infinite terms. Now, the function is given fn of x, that is equal to n plus 1 upon n minus 1 factorial x raised to n. So what I do, set the denominator into the numerator, that is n minus 1 plus 2 upon n minus 1 factorial x raised to n. Now giving separate denominator, so that will be 1 upon n minus 2 factorial plus 2 upon n minus 1 factorial x raised to n. Now in the question you are given sigma n is equal to 1 to infinite fn of x. Putting the values of the function, so here I will get sigma, I am not writing the limit right now, so that is 1 upon n minus 2 factorial x raised to n. Similarly, plus sigma 2 upon n minus 1 factorial x raised to n. Now here you can see that the factorial for the negative numbers I cannot define. So what I do, I will put the limit 2 to infinite, and here I put the limit 1 to infinite. So if I put n is equal to 2, you will get x square. If I put n is equal to 3, x cube upon 1 factorial. If I put n is equal to 4, x raised to 4 upon 2 factorial up to infinite. Similarly here, 2 removes as common, If I put n is equal to 1, that is x, n is equal to 2, that is x square upon 1 factorial. If I put n is equal to 3, so that is x cube upon 2 factorial up to infinite. Now, if you know this formula of exponential series, I can remove x square common from this first term. So here I will get x square into e raised to x. If I remove x square common, this will be 1 plus x upon 1 factorial, x square upon 2 factorial up to infinite. Similarly here, if I remove x common, so I will get e raised to x. And then after, you can integrate this up to the limit 0 to 1. Then after, question number 5. In question number 5, you are given a function. Question number 5, the function is given like this, that phi of x is equal to 1 upon 1 plus e raised to minus x. And you have to find the values of phi of 5, 4, up to phi of minus 5. Now, before we start the sum, I am putting minus x. That means replacing x with minus x. So I will get 1 upon 1 plus e raised to x. Now this term I can simplify in this form. And we can see that if I add phi of x plus phi of minus x, that is equal to 1. Now we want to find this term, that phi of 5, phi of 4, up to phi of 3, then after phi of minus 3, minus 4, and minus 5, up to like that. So if I'm making pair, phi of 5 plus phi of minus 5, that will be 1. Similarly, I can make pair these two terms. Similarly, I can make pair, and between that, there will be a one element, that is phi of 0. So first find out the value of phi of 0. That is very easy. The value of phi of 0, if I put x is equal to 0 here, so that is equal to 1 by 2. And now add the values. Then after, question number 7. Question number 7, you are given like this. Integration of 1 upon pi to pi, 1 upon x, sine of x minus 1 upon x dx. Now in this question, you have to take the assumption 1 upon x is equal to z. If I take 1 upon x is equal to z, so I can write x is equal to 1 upon z. Putting the assumptions here, so you will get that is equal to, if I put x is equal to 1 upon pi, it becomes z is equal to pi, and z is equal to 1 upon pi. This is equal to z, sine of, now x is equal to 1 upon z minus z, that is minus 1 upon z square dz. Now this term I can write, see, z and z will get cancelled, minus sign becomes the plus sign. But if I put the minus sign here to change the limit, it becomes minus I. So 2i is equal to 0, so the answer is 0. Question number 9. Question number 9, you are given f of x is equal to box of 4 plus 3 cos x, where x is given minus pi by 2 to plus pi by 2. As we can see, the x is given into the first and fourth quadrant. Now this is a box function. So greatest integer function is continuous at the fraction points and discontinuous at the integer points. So before we start the sum, first we have to write the range of the function given into the box, that is 4 to 7. Now this is the greatest integer function, it is discontinuous at the integral points or at integers. So since it is discontinuous at integers, one by one we have to take the integers. That is 4 plus 3 cos x is equal to 4. Similarly 5, 6 and 7. If I take 4 plus 3 cos x is equal to 4, then cos x will be 0. So I can write x is equal to plus or minus pi by 2, but it is not coming into the interval. Now if I take 4 plus 3 cos x is equal to 5, so I can write cos x is equal to 3 cos x is equal to 1. So cos x is equal to 1 by 3. So since x is given into the first and fourth quadrant, so in both quadrant cos is positive, so I can write two values, that is x is equal to cos inverse 1 by 3 and minus cos inverse 1 by 3. Similarly, if I take 6 here, so same term will come, cos inverse 2 by 3 and minus cos inverse 2 by 3. If I put 7 here, so that cos x is equal to 1, so that is x is equal to 0. So total there are 5 points of discontinuity. Then after, question number 11. In question number 11, you are given the question like this, that limit n tends to infinite 1 upon n, 1 upon n square, sec square 1 upon n square plus 2 upon n square sec square 4 upon n square up to 1 upon n sec square 1. It is given like this. If I express this term in the form of sigma, so it becomes like this, that limit n tends to infinite 1 upon n sigma r is equal to 1 to n r upon n square sec square r square upon n square. Expressing this term in the form of sigma. Now removing n from the sigma as common, so there will be 1 upon n square. Now it is of the form 1 upon n sigma r upon n. This is of the form f of r by n. So this term I can write in this form 0 to 1. This is x square into. Now in this question, similarly you are given this is 9 upon n square. So this is x square into sec square x square, x into sec square x square dx. And now integrate by taking the assumption x square is equal to z. Then after, question number 14th. In the 14th question, you are given that f is a real valued function such that modulus of f of x minus f of y less than or equal to x minus y square. Now this term I can write in this form also, that f of x minus f of y upon x minus y less than or equal to modulus of x minus y. In this both cases, if I take limit x tends to y, then this term tends to 0. So now I can say that limit x tends to y, modulus of f of x minus f of y upon x minus y, it becomes 0. So basically I can interchange the modulus and the limit. So that is modulus of limit x tends to y, f of x minus f of y upon x minus y, that is equal to 0. So it is the definition of the differentiation at the point y, that is equal to 0. So I can say f prime of y is 0. So I can say f prime of y is or f of y is a constant function. In the question you are given f of 0 is equal to 0. So put the values. So I can get c is equal to 0. f of y is equal to 0. Now, since f of y is equal to 0, so I can put any value of y, it becomes 0. So the answer is f of 1 is equal to 0. Then after 15th question. Question number 15, you are given like this. In the question, we have to find a minus n to n x into e raised to x into a minus x dx. Now, if I take the assumption a minus x is equal to z, So the limits will change. Now if I put x is equal to a minus n here, so the limit will be n2. Now if I put x is equal to n, so a minus n. Now x is equal to a minus z into e raised to, that is again a minus z into z is equal to minus dz. Now if I want to remove the negative sign, I am interchanging the limits, that is a minus n to n. Then expanding with the bracket, so a is constant, e raised to z into a minus z dz. Similarly, this is minus. If you see here, minus z into e raised to a minus z into z, which is given into the question, that is lambda. It is question given that a minus n to n e raised to x into a minus x, that is equal to lambda. Now as we all know, in definite integration, variable doesn't matter. So I can put lambda here, that is z into e raised to z minus that is. Now, and then after you will find the value of this term. If I take I, or so that if I assume I, then you can go further. Now, question number, then after question number 21. In the 21st question, you are given limit x tends to minus infinite x cube minus x upon square root of 1 plus x raised to 6. In the question, you are given x tends to minus infinite. So I am not removing x cube directly. First I am taking assumption minus x is equal to y. If I take the assumption minus x is equal to y, so the limits will be positive infinite. So x is equal to minus y. It will be like this. So that is minus y cube. If I put x is equal to minus y, that is plus y upon root 1 plus y raised to 6. Now you can remove y cube common from the numerator and y raised to 6 common from the denominator. Then after question number 23. 23rd question, you are given that f of 1 is equal to minus 2 as well as f prime of x is greater than or equal to 2. You are given x belongs to 1 to 6 and f is differentiable function. Since the function is differentiable, then it is also continuous function, and we have to find the minimum value of f of 6. We have to find the minimum value of f of 6. Now here the function is differentiable, so that is why it is continuous. So applying the mean value theorem, f of 6 minus f of 1 upon 6 minus 1, that is equal to f prime of c. According to the question, it is given greater than or equal to 2. Now putting the value of f of 1, so f of 6 plus 2 greater than or equal to 10. So f of 6 greater than or equal to 8. So the minimum value is 8. Then after question number 24. 24th question, you are given two parabolas. One is y is equal to x minus bx square and y is equal to 1 upon b into x square. In both the cases, b is greater than 0. We have to find the value of b for which the bounded area by these two parabolas is maximum. So now, first solving these two equations. Before I solve these two equations, first we draw the figure. This is x square is equal to by, so it is the parabola y is equal to 1 by b x square. Now this parabola, the coefficient of x square is negative, so it is a downward side and it is passing through the 0, 0 as well as 1 by b comma 0. So the second parabola will be like this. So this is the equation of y is equal to x minus bx square. Now we have to find the value of b such that this portion or this area is maximum. Now here we can see that one of the point of intersection is 0, 0. We have to find the another point of intersection. So solving these two equations, that means comparing the values of y. So I will get 1 upon bx square is equal to x minus bx square. So that is x square is equal to bx minus b square x square. So gathering the terms of x square, 1 plus b square is equal to bx. So one of the value is 0, another value is b upon 1 plus b square. There is no need to find the y coordinate because we are taking the vertical lines. That is our limits of the integration, vertical lines. So the area is equal to 0 to b upon 1 plus b square. First curve minus second curve, so that is x minus bx square minus 1 upon bx square dx. So you will get the simplification. I am not doing simplification right now, but the answer of the simplification will be 1 by 6 b square upon 1 plus b square the whole square. This is the area of this portion. Now we want this area maximum. So I have to write, since we want the maximum value, so the first derivative with respect to small b, that is equal to 0. Now we have to divide this. 1 upon 6 is constant, so there is no need to take. So that is square of the denominator, 1 plus b square the whole square. Denominator remains as it is, and into 2b minus numerator remains as it is. It is 2 into 1 plus b square into 2b, that is equal to 0. Now this denominator goes into the multiplication of 0. Removing 2b into 1 plus b square as common, 2b into 1 plus b square as common. So the remaining part will be 1 plus b square minus 2b square is equal to 0. We cannot compare this term with 0 since b is imaginary. So I can write 2b is equal to 0, or I can say 1 minus b square equal to 0. b is equal to 0, b is equal to plus or minus 1. In the question you are given b must be greater than 0, so I cannot take this value. So b is equal to plus or minus 1. Then after question number 25. Question number 25, you are given that f of n plus 1, f of n plus 1 is equal to 1 by 2 f of n plus 9 upon f of n. Condition is given f of n is greater than 0. Now, if I take n tends to infinite, limit tends to infinite, it is obvious that f of n plus 1 is equal to f of n. Both are same. Infinite is given, so f of infinite plus 1, that is equal to f of infinite. When you take infinite, it doesn't matter if you add 1 or subtract 1. Consider this term as L. If I am considering this term as L, when n is tends to infinite, the value of the function is L. In other words, I can say limit n tends to infinite, f of n is equal to L. Let us see. Now, if I applying limit to the both side, so limit n tends to infinite, f of n plus 1, that is also L. And similarly to the right side, L plus 9 upon L. Now simplify this, you will get the value of L, which is the answer.